Hi students, in this lecture I am going to talk about some sample data sets and the k-nearest neighbor. So in the first phase we will talk about some sample data sets for the machine learning. So we will use several data sets to illustrate the machine learning algorithms, and some of these data sets will be the small and synthetic data sets. That means that we will create them by ourselves, and the other will be the larger data sets and the real world data sets that have been collected from the real world data. So first, talking about the forged data sets or the synthetic data set. An example of a synthetic data set consists is a two classification data set is forged data set that has two features. This data set has two features, and the following code creates a visualization plot for this data set, and the first feature is on the x-axis and the second feature is on the y-axis. So this is always a case in a scatter plots that each point is represented as a dot. So in a scatter plot, each point is represented as a dot, and the color and the shape of the dot, it indicates its class. So first it will need to install the library, the mglearn library. So I will click it, and you will see that it is going to install. So just be patient for a few seconds, and it is going to install now. So I am running this code on the Google Colab Pro. So I have the Google Colab Pro version, and you can use the simply Google Colab. Google Colab is a free repository that you can use. And in the last lecture, I have given you the instructions, how you can use the Google Colab. So instructions can be found on the online system. So the library mglearn library has been installed, and now in this code, it is going to create a data set. Here it is going to generate a data set of 26 samples, and the two centers or the two features for the each sample. So here then it is going to plot this data set. So I am going to remove this, and then I am going to run it again like this. So here it has generated the plot where there are the 26 instances, 26 plots, 26 dots, or 26 points on the plot, and each point has two features. Because it is the scatter plot, so it is easy that we can represent the two feature, one feature on the x-axis and other feature on the y-axis. The data set consists of 26 data points and two features. Then it comes the wave data set. To illustrate the regression algorithm, we will use the synthetic wave data set. The wave data set is a single input feature and a continuous target variable that we want to model. The plot created here shows the single feature on the x-axis and the regression or target or the output, regression target or the output on the y-axis. Here is a code to generate a synthetic data set or a man-made data set that we randomly create, and there are the 40 points for this data set, and this data set has only one feature, and the other is the output. So this is a simple data set. So I just run this, and I close that and run it again. So this is the plot, that feature and the corresponding target. What is the output value? This is the input value of the feature, and this is the corresponding output value of the feature. So we are using these very simple low dimensional data set because we can easily visualize them. A printed page has two dimensions, so that no more than so that with more than two features is hard to show on a page or two dimension. An intuition derived from dataset with few features might not hold in dataset with many features. For example, high dimensional features, we cannot represent them As long as you keep that in mind, inspecting algorithms on low-dimensional dataset can be very instructive. To inspecting the algorithm for the proof of concept, it's better to run the algorithms on low-dimensional datasets so that we can better visualize, can better understand the intuition of that algorithm. Then it comes the real-world dataset, that is Wisconsin breast cancer dataset. We will complement these small synthetic dataset with two real-world datasets that are included in scikit-learn. Scikit-learn is the library of Python, and that also includes the real-world datasets as well. One is the breast cancer dataset, which the records the clinical measurements of breast cancer tumors. Each tumor is labeled as benign or malignant. Benign means no harm or harmless tumors, and malignant means cancerous or the harmful tumors. And the task is to learn to predict whether a tumor is malignant based on the measurement of the tissues. Dataset has been made by the measurement of tissues. Data can be loaded using the load breast cancer function from the scikit-learn. So here is the example of the mammogram images of the mammogram for breast cancer. So here is the mammogram image, and here there is uh, no tumor, and here in this image it shows a tumor. So Wisconsin cancer dataset has the two main classes. One is benign and the other is malignant. Benign means that it is harmless tumor, and malignant means it is harmful tumor. So these are the images from the breast cancer dataset. So here it shows the how to load the dataset from the sklearn. sklearn is also again a Python library, and it is how to load the dataset, breast cancer dataset from the sklearn dataset. So I am going to run this, and it shows that cancer dataset, and the keys for the cancer dataset, it has the data and the target names, description of this dataset, and feature names and the file names. The dataset that are included in scikit-learn are usually stored as a bunch objects which contain some information about the data set as well as the actual data. All you need to know about bunch objects is that they behave like dictionaries in Python, with the added benefit that you can access values using a dot. The dataset consists of 569 data points and 30 features. This Wisconsin dataset, it has 569 data points or instances, and each instance or each data point has 30 features. So here we are going to show the description of the data, the shape of the data, what kind of shape. The shape of the cancer dataset, the dataset contains 569 instances, both malignant and benign, and each instance contains 30 features or attributes. Of 569 data points, 212 are labeled as malignant and 357 are benign. So then it further comes the classification of the data, that which classes are in the data set. So 357 are the benign classes and 212 are the malignant classes. So I run this part of code, and then it will show the for the cancer data set, it will show the number of sample counts per classes. So 212 samples belong to malignant class, and 357 samples it belong to benign class. To get a description, the semantic meaning of each feature, we can have a look at the feature names attributes. Then we go further and find the feature names, that what each feature is. So what each kind of these 30 features is. So I run this part of code and see what kind of these features are. So each instance contains these 30 features: mean radius, mean texture, mean perimeter, similarly perimeter error, area error, etc., worst concave points, worst symmetry, worst fractal dimension. So these all count to 30. So each instance contains these 30 features. Each dot or each patient, it has been recorded these 30 features, these 30 values. Uh, you can find out more about the dataset by reading description if you are interested. So machine, there is a very famous UCI, University of California, Irvine machine learning repository, where you can go and you can find the further of this data set. So you can go there. So then it comes the Boston housing data set. We will be using a real world regression data set, the Boston housing data set. The task associated with this data set is to predict the median value of homes in several Boston neighborhoods in 1970s. So median values of the homes in Boston using the features such as crime rate, proximity to the Charles River, highway accessibility, etc. These are on the basis of these features, it is to determine the price of the house. The dataset contains 506 data points, and each data point is described by 13 features. So we see that the description of the dataset and the shape of the dataset. So it is the shape of dataset. The dataset contains 506 data points, and each data point has 13 features. Again, you can get more information about the dataset by reading description attribute of the Boston dataset. For our purpose, here we will actually expand these datasets by not only considering 13 feature as input, but also looking at the product of these features. In other words, we will not only consider crime rate and highway accessibility as features, but as the product of crime rate and highway accessibility, including derived features like these is called the feature engineering. We made a combination of different features and called it as a feature engineering, or we can see that which is the dominant feature and which is the suppressed feature and which has not effect on the predicting the output, so we can suppress that feature. So such kind of things are called as feature engineering, which we will discuss in more detail later in the course. This derived dataset can be loaded using the load extend underscore Booston function. So this is the function that can be used to load the dataset. It has the 506 features and the 104. Resulting 104 features are the original 13 features together with 9 possible combination of 2 features within those 13 features. So these 13 features, then they use the combination of these 13 features to make it 91 further features, and resulting in total 104 features. We will use these datasets to explain and illustrate the properties of different machine learning algorithms. First, we will go for the k nearest neighbor algorithm. So thank you.